Hi, welcome to the NFPA LiNK YouTube channel. This page is dedicated to answering any question or challenge you have related to electrical and life safety. And we're going to use NFPA LiNK to do it. The easy-to-use digital access to NFPA codes and standards. Today we've been asked to review the important points of residential feeder and subpanels. So let's get started. From your desktop or your dashboard, you will go to the NFPA LiNK homepage. You will select this pin that looks like a way marker on a map, and it's direct. Then you click occupancy. We're going to scroll down here to house, townhouse, or duplex. And then we're going to scroll down here to residential feeder and subpanel. The first thing that I want to talk about is what is a feeder. A feeder is basically from overcurrent protective device to overcurrent protective device. So it's basically a breaker to a breaker, fuse to a breaker, fuse to fuse, etc. The definition in the code is a feeder is all circuit conductors between a service panel or between the source of a separately derived system and the final branch circuit overcurrent device. So like the main breaker. And you will notice a couple of things. The left-hand panel and the right-hand panel both are subpanels. The reason the left-hand panel is a subpanel is because of the emergency disconnecting means. The emergency disconnecting means is on the outside and oftentimes is also the service disconnect. This may become more familiar installation because of the requirements now of an emergency disconnecting means. You'll also see surge protective devices that are now required in the code at the service or the service panel. In this case, the service disconnect is outside, so it wouldn't be there. It's going to be where the branch circuit devices are, so it would be in the basement. It also may be required out in a detached structure depending on what is all being fed in that detached structure. Typically in a barn it would not, but again, that would consult your local authority having jurisdiction. We will talk about the residential feeder conductor, and you will see here this is often referred to as the hot conductors are required to have overcurrent protection, and they are required to have the overcurrent protection at the point that it receives its power. So the overcurrent protective device would be right here, and as you see the feeder coming from above would be right here. That's going into an overcurrent device. Protection of conductors, you're primarily going to be dealing with 240.4b, and it tells you here some parameters on how you can select that, and you're going to be using table 240.6a for your breaker size. Now let's use the browser back button, and we'll scroll down to underground cable and conduit, and you'll see that that is going to be covered in table 300.5. And you will also notice that in 300.5 it gives you the burial depth depending on if it's under a driveway or if it's under green belt. That's going to dictate how deep you have to be, or if it's concrete encased and all of that. There's also the fact that if these are service conductors or were service conductors, they would have to have a warning ribbon installed 12 inches above the conduit or cable if you were using direct burial cable. And that's probably not a bad idea. It's not required, probably not a bad idea even on feeders when you're going across the yard or something, because nobody remembers exactly where they're buried, and this could prevent you from digging it up and having to redo a bunch of stuff. And you will see 300.5 is covered in here. and it gives you all the specifications. And then if we were to open this up and expand the table, you will see that it is giving all of the depths. And typically if you're in rigid or non-metallic, if you're not under concrete, you could be 12 inches. If you were under concrete, you'd be 18 in a green belt. So those are the parameters you'd want to look for. If you're using direct burial cable, you would have to protect the conductors emerging from grade. Now the sub panel is covered with working clearances. So we're going to talk about this. We're going to deal with working clearances. Service panels, everybody knows, has to have working clearances. Even though I know when I was an inspector it didn't happen all the time, but most of the time it did. We found it and we would save them from having to correct it. Just because you're dealing with a sub panel doesn't mean the working clearances no longer apply. Everything that's in 110.26A, B, C, D, E, all are going to apply to a sub panel. So you're going to have your working space, your clear spaces, your illumination. You've got to have a light. You're dedicated. That's the one that I always saw get violated the most on this, was the dedicated equipment space. They always wanted to put other things, whether it be a plumbing pipe, a drain pipe, ductwork, directly over top of the panel, and that would be a violation of the code. Our back browser button. And we will talk about, we're going to dive in, let's go to the disconnecting means. And you will see that we have a disconnecting means right here. And this is a backfed, which means if it's backfed, it must be held and secured in place. So you just can't pull it off and have live conductors in your hand. Here's the emergency disconnects. For 1 and 2 family dwelling units, an emergency disconnect shall be installed, and it tells you where you have to be installed, the grouping, identification, and etc. Also, surge protection, where they supply any of the following. So dwelling units, dormitories, guest rooms, areas of nursing homes. And that's why you see in our picture, we do not have a surge arrestor over here on this panel because it's going to a barn. We do have the surge arrestor over here because it is protecting the circuits within the dwelling unit. So, marking requirements, all of the breakers have to be marked. So if you had a main breaker, this would have to be main, listed as main disconnect. And then each branch circuit needs to be legibly identified. And it has to be clear and evident to what its purpose. It can't just say upstairs plugs, basement plugs. Well, let's say let's use the pole barn. It's going to say plugs on west wall, plugs on north wall, plugs on east wall. To that, it needs to be specific. It can't just say Johnny's bedroom, because if Johnny moves out, no, it's not his bedroom anymore. And that has to, in 40858, shall be marked with the manufacturer with the voltage and the current rating and the number of AC phases or DC buses. So that should be in the panel already, but you just want to double check. And then 23066 requires that the service equipment rated at 1,000 volts or less shall be marked to identify it as being suitable use. So SUSI labels, that's what we would call them. So let's use our back button, and we're going to scroll down, and we're going to go into grounding and bonding. You will notice in this particular instance we have a service on building number 1, and it feeds out and goes over here to the other building. Each of these 2 buildings have to have their own grounding electrode system. They need to be their own and tie back in. Whenever you have a sub panel, the neutral is isolated from the equipment grounding conductors because you have 2 separate conductors. You'll see those are all covered here in 25032. and A, and then B1. And then you have the common grounding electrode system. It just depends, again, where these are. If they were close enough together, you may be sharing the same or could potentially share the same grounding electrode system. Most of the cases, it's going to be two separate ones. And you will see here that we have an isolated neutral bar and a ground bar, and the isolated neutral bar, and they do not have the bonding there. They've got it just hung off to the side so that it can't be connected in there. So we'll use our browser back button since we've covered the grounding. And we're going to go into the sizing. And you're typically going to use 310 12A for residential. Now the residential feeder sizing, there's some relief there. And we will go in here and we'll talk about that. We'll open this up. And you will see that like a 100 amp breaker, if the service was 100 amps, it could be number 4 copper or number 2 copper clad aluminum. Well, this panel or this breaker is for 100 to 400 associated. It's got the service conductor supplying the entire load associated with a one family dwelling. You go down here to B, we'll click on B. For feeders rated 100 to 400, the feeder conductor supplying the entire load associated with a one family dwelling would be sized through table 310 12A. And so you would see, go back to our picture, that the conductors from the emergency disconnect to this panel, so these conductors right here, would be able to be sized according to 310 12A. Conversely, these other breakers coming from the underground on number 2 here, and they basically go right up here into this panel, those would not be able to be sized according to 300.12b because they are not supplying the entire load of the dwelling. So where we had used number 4 copper or number 2 copper clad aluminum for a 100 amp breaker, that would not be the same size that you would put out in that pole barn or separate garage. If you were to use those size wires, it would have to be a 90 amp breaker. We hope the review answered many of your questions around residential feeder and subpanels. Be sure to visit nfpa.org/link and give LiNK a try if you haven't already. As you can see, LiNK can increase your productivity.